In this next example, we're looking to determine the convergence or divergence of the sum from n equals 1 to infinity of negative 1 to the n plus 1 times 1 over n factorial. We will view this as the sum from n equals 1 to infinity of negative 1 to the n plus 1 times a sub n, where a sub n equals 1 over n factorial. Since n factorial means n times n minus 1 times n minus 2 times n minus 3, and so forth until you get to 3 times 2 times 1, n factorial always produces a positive number. So we can conclude that a sub n is also positive. That means we do indeed have an alternating series. So we can look to apply the alternating series test. The first thing we want to do is look at the limit as n goes to infinity of a sub n. That is the limit as n goes to infinity of 1 over n factorial. Now, as n goes to infinity, n factorial means we're multiplying larger and larger and larger numbers and more of these numbers together. So n factorial will go to infinity also. That means we have a 1 over infinity determinant type, which tends to 0. That meets the first condition on our alternating series test. The next condition is we need a sub n plus 1 to be less than or equal to a sub n. That is, we need the sequence of a sub n to be non-increasing. So let's write out the definition of a sub n plus 1. This means we have 1 over n plus 1 factorial. 1 over n plus 1 factorial can be rewritten by iterating terms. So whenever you see a factorial, try to iterate to a term that you want to use, either for cancellation or in this case, so that we can identify the term a sub n. And we have n plus 1 times n factorial. Or in other words, we have 1 over n plus 1 times 1 over n factorial. That means a sub n plus 1 equals 1 over n plus 1 times a sub n, which is less than or equal to a sub n, since n is greater than or equal to 1 and a sub n is positive. So, by the alternating series test, we can conclude that the sum from n equals 1 to infinity of negative 1 to the n plus 1 times 1 over n factorial converges.